Klaus.
Yep, thank you, Klaus. I do want to ask you though, Klaus, and we talked about it a little bit in the chat. Let's talk about the data rate on that transaction log expansion. That was nearly 900 megabytes a second. What is underneath?
My time
that
is
data
already
rate?
over. I'm finished. I've already seen that email about the after party. Sorry. The 900 megabytes I'm using here, nothing special. I have here VMware, and I'm using a vSAN data store in the background.
Oh, okay.
With flash devices.
Many flash devices.
Yeah.
Anthony, if you were impressed by the 800 megs, you should not attend the next session.
Well, I'm saying I'm working under the assumption.
Talk. Oh, I like it.
I'm working under the assumption that's his home lab and not the stuff that
29 gigabytes per second for log writes.
Right, but that you have probably a different budget than Klaus has in his home lab.
Yeah, I probably spent less on it because I'm not using a SAN. That thing is actually not expensive. I'm not joking. This stuff is not expensive anymore. This is the big difference. I unfortunately legally I cannot talk about the vendors and the pricing because that gets us all in trouble. So I avoid that. But
it's okay. You can tell us. No one will know.
Right. Let's stop the webinar for a second.
Thing is, and I like the lineup today. We had the data compression, which basically deals with high level. Hey, this is my tables. Then we had the query processor. Then we had the logs and spin logs and all the in-memory details. And now I'm rounding this whole thing up with okay. And now let's start tuning the underlying hardware.
Totally done on purpose. Honestly.
It's almost like we planned it that way.
Yeah.
It actually should have been between the Bob and Amit should have swapped, but I get it for him and presenting from India is.
yeah, because I think it was 7:30 his time when we kicked it off today. 7:30 p.m.
We're going more and more down the stack during the day, and I like that. So.
That's the goal.
Yeah, and yeah, it's where you need to be. I mean, there's millions of machines where stuff that Klaus and I are doing has no effect because it's not needed. But when you need it, these things are very, very helpful.
Yeah.
Hey guys, I gotta drop. This was wonderful, Klaus. You're wonderful. I was sitting here taking notes, so I missed some of the questions when they first came up because I was taking notes. So that was awesome. And
thanks for handling the questions. Thank you.
Absolutely. And thanks, Anthony and Andrew and Mark and everybody else who is putting this together. This is wonderful once again.
Angela, thank you so much. A fantastic job.
Awesome. Thanks, guys. I'll see you later.
Thank you.
Thank you.
Bye.
Bye. Thank you.
So all the attendees, you know the drill by now. We've said it a few times. Please do go ahead and leave some feedback for Klaus and the event on that link on the screen there, 8kb.online/feedback. We can only make this event better by hearing from you. So please do go ahead and tell us what you liked, what you didn't like, and give us some comments as well. And so up next we have Thomas with scaling SQL Server beyond 2 CPUs. You've already given us a bit of an introduction, but we'll give it a little bit, and then we'll get started at the top of the hour.
Can I take a poll while we're sitting here?
Oh, absolutely.
So, biggest box. I know Tom's going to talk about beyond 2 CPUs. I'm not sure how many you're going to talk about, but biggest box you've worked with thus far.
Right. I'm currently working on a 96 core, 876 gigabyte system. There's 4 servers like that, which is insane.
Does this have to be production work?
No, I did. I was going to use proof of concept work, which I did on a whatever the highest one in Azure is. So 400.
Where's Joey? Joey.
Yeah, whatever. Joey probably know it off the top of his head. 400
right?
some vCPUs and 11 terabytes.
Whoa. Jeez.
That sounds like fun. I think that one's just called $signs.
Right.
What was that used for? A SharePoint farm?
No.
Just one.
No.
Just one.
And that here's the kicker: like bigger hardware. Jonathan says this a lot. Bigger hardware, bigger problems.
Oh yeah.
Right?
Well,
So
my experience was on a 128 core box, I think, and it had maybe 3 terabytes of memory. And the bigger problems came in. It was running SQL on Linux. I was running a load test against it, and something happened. Something hung. CPU was pegged at 100%. We had to reboot it. Took like a half an hour to reboot because it had to go through all the memory on boot up. So definitely bigger problems. Yeah.
Yep.
Yes and no. If you know how to configure these machines, all these problems go away.
As usual.
That's why you're here.
To brag with my numbers, I'm trying to frame it a little bit to me. It's 1.75 kilo cores, so 1,750 cores.
Kilo cores.
That's
That's a new metric.
New unit.
I'm not good at math, but that sounds like a lot.
What did the licensing people say when you tried to license that?
Thank you.
Yeah.
Thank you.
You license them in kilocores.
So you declare that development. No, it's the licensing is a yes.
Hey kids, we're going to
Things I can
Disneyland.
talk about and things I cannot talk about. If you have a box like this, you should talk to Microsoft about license.
I would imagine the salesperson just calls the yacht salesperson right afterwards,
You're
right?
not talking to the
Right.
salesperson.
No, probably not.
The sales guy is nice enough to introduce you to the person you have to talk about. No, and don't forget, cores is not equal to CPUs and stuff like that. So there's a lot going on there, and yeah, but it's fun to work on, and we will look at it. But it's
Is that box busy?
yes, I can push it to 100 at any point in time by doing like an index rebuild or so. It should not go busy during normal operations because that's the reason it's that big, so that there's always buffer to do more.
Got it.
Yeah. And the funny part on that box, the limit is not the CPUs. The limit for a long time is memory. That box is only constrained by memory.
How much does it have?
No, it's not the size, it's the performance. So it's 32 times
He's got his calculator.
it's 48
Printing tape.
It was what, Thomas?
48 terabytes of memory.
Wow. How is it cooled? Is there just like a dry ice thing in the fan that's blowing at it?
It's 8 boxes that are just regular, look like a regular server. They are 8 4U boxes. And the reason for the 4U boxes is we choose the option that has more I/O. The I/O is the more impressive thing. I don't know where the limit is yet, but I've seen more than a terabyte per second table scans. So
Wow.
that's the thing. You stop using indexes when you can read that fast, because they just do that.
Don't give people bad
Yeah.
ideas.
Yeah.
Don't say that.
My hardware is fast enough. I don't need indexes.
Mark, you know, when you're doing your editing for this, you just chop that bit out.
Wait. No, yes, there's cases so where indexes make a lot of sense, but we use this box for 2 cases. One is high concurrency, and the other one is data warehousing. And on the data warehousing side, we're doing table scans on very, very large petabyte-sized tables. And yeah, we all know when you have to read a petabyte, adding an index to that, it's not going to make a lot of a difference because SQL is not going to choose it. Yeah.
Is it column store?
Some of it is in column store, some is not. It depends. Some stuff is really good. If you need to scan it all, then column store is great. If you need to just scan like portions of it and you can't partition and you can't these segment group eliminations doing for it,
Yep.
then column store is not your friend.
I was going to ask if you partitioned it. That was my next question.
Yes. So column store we do no data type can be more than 8 bytes. We do the we pre-sort the data, we insert
Before you load it.
1 mega rows at a time,
Mhm.
and we learned that. I have a whole talk on it.
You
It was a learned process to get it right. And currently the largest table has 3 to 4 trillion rows, and grows by several billion a day. And
I think that loading piece is often not understood, right? And then you have your row groups and all of that.
what we do in the loading is we have multiple in-memory tables.
Look at Thomas using all these features, man.
The application pre-sorts the data into the loading tables by grouping it, kind of. Loading. And then once we have a mega rows in there, we sort it one more times and then load that into the column store. So by doing that, we could not only reduce the size massively because we have the repeating columns right next to each other, but it's also the partition elimination. So if we have one column that we not partition elimination, the segment elimination, we have one column, the segment will only contain one value.
Yep.
So it's perfect for eliminating it. Yeah, but that takes a lot of energy to get that in. And,
it does.
Yeah.
It does. That's a whole session right there.
Yes.
I think we just had a whole session.
Right? That was like a mini session.
I think
I'm starting to think scaling SQL Server beyond 2 CPUs is a little bit of an understatement for what's coming up.
I'm just trying to wrap my brain around the development team, having worked with the database people, to have both things be nice to the other thing. That's nice to hear.
I was just going to say, I think the real missed, the talk everyone wants to hear is how you convince the developers to sort the data before they put it in the database.
Right. So what you normally have is you have application developers and then you have DBAs, and that doesn't work. What we did is we put a group in the middle that we call database developers. And they had to take the code from the application team and make it database friendly. And then the DBAs didn't kill them. So to use Gail's methods of doing things. No, it's you need people that understand that it's the problem is the developer has the goal to get as many features out as possible, and the DBA has the goal to keep it as stable as possible, and that doesn't gel. Yeah, and if you have that group in the middle that has just one job to make this what they make to run fine here, you get a lot more done here because you're not spending all day long with fighting issues because the people in the middle know how to avoid them to begin with. It's not that hard. They just listen to the DBAs and then they take the stuff from the application group and figure out how to run it by the rules and not just by random stuff.
Listen to the DBAs.
Yeah, it's a hard.
Gonna hold on to that one.
So serving them vegetables in form of beer.
Nice circle back. Nice.
Yeah.
I think all of the database engineers that work with Andrew and I are rolling their eyes at us right now.
Okay, I'm going to stop sharing my screen, Thomas, if you want to grab it.
Click share screen. That sounds good. Let's take this one.
Have a great session, Thomas.
You too. Thank you. Shift.
There we go.
And how would you like to handle questions? I've got the Q&A panel up. So, very good. I have to remember pictures. Oh man.
Yeah. So if it looks like this, it's a good point to pause. I will try to pause. If I don't pause, just interrupt me. This slide will repeat a lot during the presentation because I use it to do things. So let's go to the real one.
No problem. Slides are all yours, Thomas.
Yep. Should be.
Crack on. Have a good one.
Yep. So I start a minute early. That's fine. A minute longer I can take.